Hey everyone, welcome to the first video in the Ghidra Automations and Scripting series. I'm your host, Dr. K. Today, we'll kick off the series by providing a light introduction to Ghidra scripting and the Ghidra API. If you've never scripted in Ghidra, or perhaps you find yourself drowning in API docs on a regular basis, you're in the right place. As with all things reversing, my goal with this video is to demystify a concept or technique that you may have previously deemed some sort of dark magic. The Ghidra icon might be a dragon, but I promise, unfortunately, there's no epic fantasy here. In this video, I'll be referencing the Ghidra API Jupyter Notebook. If you want to follow along and complete the exercises, and I definitely recommend that you do, you can get the notebooks via our GitHub channel. I've linked the channel below. Let's dive in. The Ghidra API provides a set of classes and methods that we can use to access and manipulate data in Ghidra. In the current version, the API is available in both Java and Python. It allows us to automate tasks such as code analysis, program modification, and scripting. The API documentation alone is vast, and it can be a bit intimidating to navigate. The Ghidra API is organized into several packages. Some of the most important packages are things like Ghidra Program Model and Ghidra Program Database. Here are a list of all of the packages that are available. Let's find one of interest. Ghidra Program Database. This package provides classes for accessing the program's database, such as the Program DB class. We'll see this class again in a moment, but in summary, the package provides us with access to both the current program and the function manager classes. The Program API defines an object hierarchy many levels deep. It's rooted at the top by the program class. The Ghidra API is comprised of numerous packages, classes, and associated methods and functions. Your primary resources for these things are the built-in Ghidra documentation and pre-built Ghidra scripts. So we open an executable in Ghidra. To script in the GUI, we have two main options, the Python prompt and the scripting manager. Anytime you run a script, you're going to be handed the current state in the form of a class instance variable. You can start typing the word current in the interpreter and hit tab to see these variables, current address, highlight, location, program, and selection. We'll double click on current address, and the address of the current cursor location in the tool is returned. Sure enough, we see that our cursor is at that address. Pretty cool. Let's try another one, current program. So current program, again, is accessible from all Ghidra scripts. It's a Ghidra Program Database, Program DB object that allows us to interact with the database for the program that's currently being analyzed. Typing current program.tab shows us all of the things that we have access to from that object. For example, current program.creationDate gives us the date that the program was created. Now it's your turn. In this first exercise, I want you to explore some of the methods that are available to you using current program. I've provided a short code snippet in your notebook as a place to start. I've also hyperlinked the API. Simply navigate to the program interface and identify the methods that you wish to leverage. Then pivot back to the GUI and test from the Python interpreter. Good luck! Now that you've had a chance to look at some of the methods that are available to you using current program, let's try to do something a little more interesting. Specifically, we'll take a look at functions. In Ghidra, a function is a block of code that performs a specific task and can be called multiple times from various locations in a program. In the context of a binary, all this means is that a function is a sequence of instructions that are executed together in some specific order to perform a specific task. Functions in a binary are identified by Ghidra using a bunch of different techniques. Ghidra can do things like analyze the control flow of the program. It can use symbol information, and it can use information from external sources. In essence, Ghidra uses a function detection algorithm to identify the start and end of functions in a program. You can use the Ghidra API to access functions in a binary using Python, and specifically, we can use the function manager class. This class provides several methods for accessing functions, such as get functions, which will return the function at a specified address, or get functions, which will return an iterator for all of the functions in the program in either the forward or reverse order. In your notebook, I provided some example code that's actually provided by Ghidra. Let's test this out. Simply copy the code, go back to your interpreter, paste the code, hit enter, enter, and you can see that all of the functions in the program are printed to the screen. While the Python interpreter is great for simple code, as our scripts grow, we'll need to pivot to something a little more sophisticated. For this, we'll leverage the scripting manager. Selecting Window Scripting Manager will pop up a new window that contains over 280 scripts. We could run any of these by simply double-clicking them. However, in this example, I want to create something new. To do this, I can click on the scroll-looking icon, then select the language that I want to write my script in. Now, I have Mandiant's free plugin, Ghidra installed, so I can use Python 3, and that's what I'll do. Finally, I name my script, and voila! I'll copy and paste the code from before, but right away, I can already tell that it's going to fail. This script was written for Python 2, so the print statement syntax needs to be updated. After updating, I can resave the script and click play again. Now, the names of all the functions are printed to the console. I provided an alternative method to access functions that I find to be a bit more intuitive. Using current program, we can get the function manager using a method called getFunctionManager. After getting the function manager, we can get an iterator over all of the functions in the program. To do this, we can use a method called getFunctions. Finally, this will give us access to a ton of methods for every function in the iterator. In the final exercise, you're going to leverage this technique to access information for each function in the program. For example, function 1.getName should give you the name of the function. You may have noticed that a parameter was being recurrently passed to some of the function-related methods. What in the world is this task monitor? Well, to put it simply, it's an object that monitors a task. Let's see it in the API. And here it is, in get called functions and get calling functions. Let's demystify this. In the Ghidra API, the task monitor is an interface that allows you to monitor and control long-running tasks. It provides methods for checking the status of a task, updating progress, and canceling a task. Often, the task monitor is passed as a parameter to an API call, as we saw in the last example. This would allow the user to control how long Ghidra can spend on the analysis. The caller can use the monitor to display a progress bar or a status message, and to provide a way for the user to cancel the task if desired. In the current version of Ghidra, we typically don't need to create a task monitor object ourselves. Ghidra provides a default monitor that we can use in most cases by either passing null or none, depending on the language that you're scripting in. Alternatively, if we need more control over the task, like we want to display a custom status message or we want to monitor the progress, we can create our own task monitor and implement and pass it as a separate parameter to the function call. For example, consider the following prototype decompile function, which leverages the task monitor object. When we call decompile function, we can either pass the default task monitor by specifying none, or we can implement our own task monitor in this case called My Monitor. I hope you've enjoyed today's video, where I introduced the Ghidra API and aim to demystify some of the concepts and techniques associated with Ghidra scripting. Feel free to check out the rest of the videos in this series, where we do things like extract the frequency of mnemonics in a binary, or identify potentially vulnerable functions in a batch of binaries using Ghidra headless. Until next time,